Today I'm going to be talking about several Wolfram Cloud-related technologies, all with the common theme of how they can be used in a real-world application, specifically this device here, the Amazon Echo. Now, you come to a conference like this, or you look at some of our promotional web pages, you're exposed to an almost bewildering variety of cloud technologies. And it can be hard to know where to start, what's useful for what, etc. So I think it's very useful to see a concrete application and how some of these technologies fit together to solve problems and create interesting applications. I hope that the Echo provides an engaging example for that. So let's meet the Echo. It's really, you can think of it as something similar to Siri. It's a personal assistant. One advantage it has over Siri is that Alexa is always on. But the most important thing about the Echo, as far as I'm concerned, is that it has a completely open programming model. Amazon lets you extend the capabilities of the Echo by writing your own simple REST-style web services. And this is the killer feature for me. This is the reason I bought the Echo. I was poking around. I thought this might be interesting. I said, whoa, I went to their website. They got a whole SDK. It's like, I knew right away that this would be a great application for Wolfram Cloud stuff, that you could write some very, very interesting things with the Wolfram Cloud. I think that I wonder if Apple will have to open up Siri in response to competition like this, because it's really useful to be able to extend this thing. So let's meet the Echo here. Now, the device is called the Echo, but the voice and the personality in the Echo is named Alexa, and that's the word you use to wake it up and talk to it. So I will often call the thing Alexa, or refer to it variously as Alexa or the Echo. And I've turned her off for the moment because she's very sensitive to hearing her name. So if you say, I'm talking about Alexa, she's constantly waking up and complaining that she doesn't understand what you're asking. She's, the computer HAL has nothing on Alexa. You whisper her name in the back corner, she'll wake right up. So I'm going to turn her on here. Yeah. So anyway, Alexa, what's going on in the world?
Here's your flash briefing. In NPR News from TuneIn.
So,
From NPR News in Washington, I'm Corva Coleman.
All right, so she has music. She could link to all sorts of services like that. Has all sorts of information. Like, Alexa, tell me about Canada. Alexa, tell me about Canada.
Canada is a country consisting of 10 provinces and 3 territories in the northern part of the continent of North America.
Fascinating. Bet you didn't know that. And the thing about Alexa that is really the game changer for me, as I said before, is that it's always on. Just the fact that I can just turn my head and say something, ask something, I don't have to do anything. It really, that one little difference, it makes all the difference in the world as far as I'm concerned. All right, so some of the technologies we'll be talking about instant APIs. That is, these API functions that you can deploy into the cloud. And that's really the main technology we'll be using. I'll show some applications with the Wolfram development platform, the web interface that we'll be using at times. We'll talk about the Wolfram Alpha API. We'll talk about some new publish subscribe functionality that's coming to Mathematica. We'll be talking about deployed notebooks and report generation, which is an example of a scheduled tasks in the cloud, and then probably very briefly some use of the cloud mobile app. Okay. All right, so now let's talk about, we're here to create our own Alexa skills. They're called skills in the world of Amazon terminology. So how does this whole thing work? So there's 3 actors in this. There's the Echo itself, Amazon, some server sitting somewhere, and then the Wolfram Cloud is where we're going to deploy. Now, we're going to be, of course, using the Wolfram Cloud to deploy these Alexa skills, but you don't have to, obviously, use the Wolfram Cloud. You could use your own private web server, your own web hosting service that you want to, if you want to use some technology other than, Wolfram language. And Amazon itself makes their own service available for, Java or JavaScript development if you want to write your web services in that way. All right, so step 1 is you deploy your web service to the Wolfram Cloud. The things in blue are the things that you have to do as a programmer. You deploy your web service to the Wolfram Cloud. I mean, we will talk about all the details of these things later, of course. So that's like your cloud deploy of API function, blah, blah. Then you have to define and register your skill with the Amazon Developer Portal. So you have to tell Amazon about, you know, the parameters of this Alexa skill. So here's an example maybe of, let's say you've written some skill called daily quotations. And so here's the flow of events. The user says, you know, ask daily quotations for today's saying. So that goes to the Amazon server. Now you don't care about this. As a developer, I don't care or know anything about this first step with a link. I don't really care about Alexa's communication with Amazon. I only care about the right-hand side here, Amazon's communication with me in the Wolfram Cloud. So you ask daily quotations for some saying, and then Amazon sends to some URL that you have told it about. It sends an Alexa request, and this is just a big package of JSON, or actually kind of a small package of JSON. So then your Wolfram Cloud API will have to handle this JSON. It sends back an Alexa response, which is another little bundle of JSON. And then the Amazon server sends back to the Echoes, you know, the result, and Echo speaks it. So it's what happens here on the Wolfram Cloud side. Your responsibility is to handle this incoming bundle of JSON with various information in it, and to create this outgoing bundle of JSON with various information. Okay, so very simple. So let's talk a little bit about what an Alexa skill looks like, or what, you know, the steps you have to go through. You have to define your voice interface. And there's two aspects to this. There's the intent schema, and there's a set of sample utterances. And I'm going to go through this quickly. You don't really need to care about the details of some of this stuff, but it's a little interesting to kind of understand how this stuff works. So this is an example from the developer website, a very frivolous example of a horoscope application, horoscope skill. So let's say I want to write a horoscope skill, and every skill will have certain, they're called intents. They're like actions that you might want to take. So this horoscope skill has two intents. You can ask to get a horoscope, or you can ask for, you know, get your lucky numbers for the day. Very, very valuable application, by the way. So, and then, so you define, this is how you define the intents and essentially the arguments they take. So the slots here are the things that you fill in. So you might say something like, ask, you know, horoscopes to get get my horoscope or something. And that's mapped to this intent. You'd say, get the horoscope for Virgo or something, right? And so Virgo would be the sign slot, and then this, you know, this type list of signs, that's a user-defined type. You can define your own set of types. Obviously, list of signs would be defined as the set of zodiac signs, and you could ask for a sign and, you know, a date. So what's the horoscope for Virgo on, you know, July 7th or something, and that's a date type. So anyway, that you simply define your schema of intents, and then you define some sample utterances, and this is the not really the tricky part, but where you put the most thought. So this is where you tell Alexa what you're going to be saying that should map to certain intents. So what is the horoscope for sign here? This is what I would say to Alexa, you know, this part right here. What is the horoscope for Virgo, say? And this line tells Alexa that if I say what is the horoscope for Virgo, that should map to the get horoscope intent, which is defined above. So, yeah, I said her name. So typically you'll have a very long list of these things because you want your users to be able to have a wide variety of things that they might say to activate this intent. You don't want to force them to say a very precise set of words. So you can see they've got various ways. Get me my horoscope, or what is the horoscope, or you might, if you had this for real, you would have a whole bunch of these, like, you know, tell me the horoscope for blank kind of thing. So that's what some sample utterances might look like. And then, so So I know you don't care about this, and I'm not going to go through it at all, but so this is what Amazon sends you, this bundle of JSON, and you can see that there's information in here. The intent at the bottom here is get horoscope intent, and it fills in the slots, the sign, and the value. So obviously, when you're writing your web service that responds to this JSON, you're going to have to, you'll look up you want to know the name of the intent, get horoscope, and you'll want to know Virgo. You'll be picking that out from this bundle. And so, of course, Mathematica, the Wolfram language, can import JSON very easily. I just ran that simple little import just to see. It just returns into some nested set of associations. So fine, I'm done. This is the first thing I did when I went to the website. I said, okay, fine, I got some sample JSON, imported it. You see what it looks like? The rest is just details. Teasing apart this association to get all the information that Amazon sends you is quite straightforward. And then here's your typical JSON response maybe. This is what you need to send back to Amazon. So you'll have to create JSON that looks like this. And Wolfram language also has a very simple way to turn an association back into JSON. Export does that for you. So you'll just build some association, you export it to JSON, and something like this will come out. And of course, this right here is the output speech part of the response is the thing where you would be filling in what you want the echo to say. All right, fine. So let's talk about instant API. So now we're going to talk about the details of writing the service that Amazon will be talking to, that's running in the Wolfram Cloud. So the Wolfram Cloud makes it very easy to deploy Wolfram language code in such a way that can be accessed as a standard REST-style API in the web. REST-style just means that the data it's not using SOAP or some complicated protocol where you have a large set of, a big payload that you have to deal with. It's a very simple concept. So here's an example. You've seen this sort of thing before, a function that adds 2 integers. So this first argument API function is a list of of slot names, parameter names, I and J, and their types integers. So Wolfram Cloud automatically handles sort of parsing an integer out of the data that you supply for these parameters. And then, pound I plus pound J ampersand, that's the block of code. That is the functionality that you're deploying on the web, just adding 2 arguments. This is all you need to do. Really, what goes in here, and of course the parameter types, but what goes in there is arbitrary piece of Wolfram language functionality. So it's this simple to create some extremely powerful, complicated piece of functionality and make it available on the web to any caller from really any language or environment. So if I run this, I get back some cloud object. And so this URL, this is the URL that I can use to access this. So if I click on this, my browser launches. So if I click on this, you can't see this. Oh my gosh, I get some error. Well, that's just because I didn't define the I and J parameters. I'm going to put this in the URL. I could use this form to add them, but I would just say, question mark I equals 2 and J equals 3. So if I fix the URL, then in the far upper left is a very small 5. All right. You get a result back. It's a very small result. All right, so I've just used a web browser to access this URL, but of course I use Java. Any programming language I want, any environment lets you call these sorts of APIs. So in just one very small line of Wolfram language code, I've deployed a piece of functionality that I wrote to any client anywhere in a very, very simple way. All right, now there's one complication here, which is that the web API call that Amazon sends doesn't have named arguments like a typical call. They're not, it doesn't have it doesn't have input equals blah in the URL or in the post body. It just has a block of JSON code. So how do I get a block of JSON code out of the HTTP request? Well, there's a function called HTTP request data. If you put this inside your API function, you can get various aspects of the HTTP request. You can get the headers, or in this case, the body. So this is a little tidbit that's not obvious because almost all the examples of API functions have these named arguments. But if you just need to get the entire body of the post request as a single string, you can just say HTTP request data of body. So these API functions that are created, you won't really see them because I've written a package that simplifies all this. But inside, they get the JSON by calling HTTP request data of body. All right, so now let's create a simple echo skill using the Wolfram cloud. So this is going to be one that just echoes what the user says back. And this is actually quite useful because, I created this as a testing thing because it's actually useful to know exactly what Alexa hears and what words she leaves out or doesn't leave out. So there's only one intent. This is my intent scheme. There's only one intent called echo intent. I'm naming it input. And the type is literal. So this is what literal means, any old string of text. So what this silly looking set of sample utterances means is that I just put in the words in here, like what is the longest input that this are just gibberish, all right? I just need to have a 1 to 10 words or 1 to n words in this thing. So if I just had, what is here, then the service probably wouldn't recognize a 3-word statement. See, so I just put in, I could make this longer if I wanted, and then I could say even longer strings to Alexa. So anyway, so I write this sample utterances and intent schema. So I've deployed, well, I haven't done that yet, actually. All right, so let's deploy the API function. So we say it needs Alexa. I've already defined this. All right, so the endpoint here, this is the URL that I'm going to, it's been truncated here, but that I need to tell Amazon. This is where I'm deploying my API function to this URL. And I've already created this cloud object address in the past. So when I deploy my Alexa skill, I want to redeploy to the same URL every time because that's the URL that Amazon knows about and is going to call this skill on. So anyway, this is my function. This is the function that does the work. And this, as you can see, there's this Alexa response. I've written this Alexa package to make this stuff simple, but it's a very simple package. It's like a page or two of code. So I can just say, Alexa, the output speech is the thing that the echo will say back, and get slot, that's just extracts the thing coming in. So this just returns the input that was coming in and sends it back out as the output speech. And then this function deploy Alexa skill, which is the thing that deploys the skill to that endpoint. So now the API function is running in the cloud. So what I would do now is I would go to Amazon. This is their developer website, my list of skills. And so if I go to echo input, it's going to probably fail here because I have to re-log in. But let's just take a few clicks. All right. So anyway, you go here. Here's where you provide, I guess you can't see this because it's incredibly small, but it doesn't matter. I provide the name of my skill and the version. And this string down here, this is the URL, that cloud object address that I deployed my skill to. So this is the address that Amazon server will talk to when this skill is invoked. And then the interaction model, this is where I put my sample utterances and my intent schema. And then I'm done. I fill those things in, and this is how I register my skill with Amazon. All right. So let's try it. So I have to say the name of my application, which is echo input. So I say, Alexa, ask echo input to repeat what I said.
Repeat what I said.
Okay, so there we have it. I just wrote basically one line of Wolfram language code, deployed it to the Wolfram cloud, went to the website, registered the skill. And once that registering of the skill is a one-time operation, I can change this all I want. Here, let's just say, if I want this thing to say hello, instead of echoing what I said, I can just redefine that, redeploy. And I say, Alexa, ask echo input to repeat what I said.
Hello.
So anyway, just to prove that this is all live. Anyway, let's leave it the way it was. Now, one thing you'll notice is that when you talk to the echo, you have to say, watch her get confused. If I say, Alexa, ask echo input, say something.
I can't find the answer to the question I heard.
Yeah, you see, it needs that word to. You really have to phrase it as a, if I have to say, Alexa, ask echo input to say something. Alexa, ask echo input to say something.
Say something.
You have to have the word to there. And you can also say, Alexa, tell echo input to say something.
Say something.
When I'm testing, I found quite a few times I'd forget to put that first little word that makes a real sentence out of it, and she gets confused. All right, so there we have it. We've created our first echo skill and deployed it to the echo. And everything else is just how fancy do you want to get with your skills. So what's the first thing that anyone does when they start developing an application? You build a game, right? So let's play a game. The license plate game. So the point is that this works great in New York State where I grew up because almost every car had a 3-letter sequence in its license plate. So you're driving along, you're bored, car goes by, you get the 3-letter sequence from the license plate, and the idea is to come up with words that have those 3 letters in exactly that order. Now they don't have to be consecutive in the word, but they have to be in that order. There's 3 points to be had for each license plate. 1 point for the first person to come up with the word, 1 point for the person who comes up with the shortest word, and there's another point for a word that has the letters consecutively. So I thought of this game, it would be a perfect example for the Wolfram Cloud because Mathematica has a dictionary lookup. It's a full English dictionary. It's very simple to ask, to generate 3-letter sequences at random and look up, find if they match words, et cetera, et cetera, et cetera. So I wrote a simple implementation. So let's play. Now, we're playing this game for real here, so I want people to participate. Alexa, ask license plate game to start another round.
The letters are N, R, F.
Come on. Alexa, ask license plate game to give the answer.
The shortest word is sunroof. There are no consecutive words.
Sunroof. That's a good one. Good one. Okay, well, let's play it. That's the game. The implementation, really, now that we've played it, you can see there's 3 intents. We can ask Alexa to start a new round. We can ask it to give us the answer. We can ask her to repeat the letters. And so here's some of the utterances, right? So you can see I want to have a lot of flexibility in what I can say any of these things, and Alexa will give me the answer. So I just write you think about various ways that you want users to be able to interact, so here's the code, and I just want to show you about how short it is. Cheating a little bit, there's a few functions here, like in a license plate game package, generate letters. These are relatively short functions. I don't really have them in line for no particular reason. So there's just about that much code is needed. And then here's the deploy Alexa skill. So deploy Alexa skill, you map various intents to functions that are handlers for those intents. That's simple, right? I just say that the launch, which is the thing when I say ask it to launch the license plate game, that starts a new round. It's the same thing as asking for a new round. The answer intent maps to the give answer function. So it's very simple. I just associate each of the intents with a Mathematica function that handles that intent. Okay. All right. So now let's look at another example, which is Wolfram Alpha spoken answers, or why should Siri have all the fun? People probably know that for a long time, Siri has given spoken result answers that come from Wolfram Alpha. And we have a business relationship with Apple that made that possible. That feature is available in the Wolfram Alpha API, although it is an extra cost feature. So that's not, if you're just doing free Alpha API queries, you can't get spoken results. You have to have a special app ID that lets you do that. I have such an app ID, so I can write that. But if you were doing this for real, you'd have to talk to us in business development. All right, so anyway, this is what a call to the Wolfram Alpha API might look like. URL execute is just a convenient function in Mathematica for fetching a URL that allows you to specify the parameters in this sort of symbolic way. So you say spoken result goes to true in the arguments. That's the magic that lets you get back spoken results. And this is, you get back some XML thing back. This is what it looks like in Mathematica. You don't really care about any of this stuff, but this one element here at the bottom, the spoken result element, is the thing that has what you're looking for, and you see the sample text, the answer is 4. This is the thing that Siri reads out when you ask Siri what 2 plus 2 is. I don't actually know if Siri goes to Wolfram Alpha for 2 plus 2, but for other queries, it does. All right, so I just need to write something that makes queries like this to Wolfram Alpha, and you'll get back XML like this. I just have to pick apart the XML to find this sample text. All right, that's a piece of cake. The implementation, there's only one intent, which is to ask a question. I call that the query intent. And again, here, these are just gibberish strings of, I can ask queries that are up to about 14 words. So anyway, I know you don't care about this. I'm not going to talk about the code at all, but this is the only thing I had to write. This do query function, this implements the entire thing. It just simply gets the user's speech, it formulates a Wolfram Alpha API call, makes the call, picks apart the spoken result, and sends it back to Amazon. And then it can be deployed just like that. I've already done that, of course. So anyway, let's play around with that. So I say, Alexa, ask Wolfram Alpha how many calories in a cup of broccoli.
The answer is about 26.9 dietary calories.
Didn't know that. Okay, Alexa, ask Wolfram Alpha, what is the mass of a boson?
It looks like the answer is about 1,330 gigaelectron volts per speed of light squared.
Did you know that? Okay, so Alexa, ask Wolfram Alpha to integrate sine x from 0 to pi.
It looks like the answer is 2.
Yay. Don't get too excited. Alexa isn't great at interpreting spoken math. That's a pretty simple example. If you give it some more things, you could probably try to clean up what Alexa thinks you said. You could write some code to clean it up, but it's not great at understanding spoken math. So there we have it. We've turned Alexa into, here's her name again, Alexa, stop. Turned her into the same capabilities that Siri has with Wolfram Alpha. And that was, you saw, that was the entire amount of code that was needed to do that. All right, fine. What I really want, though, is visual output. And I think actually this is a really killer application for the Echo. I think that, voice responses are great, but I think that if you had, in conjunction with a screen, this had some inexpensive screen mounted on your wall in your kitchen or something in your living room, and you say something to Alexa, and Alexa can put something up on a screen. I think that's really, really interesting use case. And Alexa does have, I should turn her off while I'm talking about her. Sorry. We're going to talk about her now. It's okay. You know, you can send these little cards to your phone, for example, the Alexa app on your phone. So in addition to voice output, you can send a little card that appears on your phone. But currently, the feature of that is it's just pure text. There's nothing else. You can't send a clickable link. You certainly can't send a picture. And I know that Amazon will change that because it's like the #1 requested thing on the developer forums. But right now, the sort of visual non-voice output from Alexa is just a trivial string of text. That's the only thing you can do. So, but I like to imagine, you know, a screen in my living room or something, and I can talk to it, and it gets a visual output. So let's see how we might do that. So if I want to do visual output, I do need to push something at, and I'm going to use Mathematica as the client that does the display. It doesn't have to be that, but of course I'm running Mathematica, so I'm going to use that, and it's very easy to set up. So the cloud needs to push something at my copy of Mathematica. So how can I do that? Well, we have this new feature which is not in Mathematica yet, but it's coming very soon. It will probably be available, I'm guessing, as an automatic update in between releases. I'm not sure about that. It's this publish and subscribe notion, or channels as we call them. Now, people might be familiar with this concept. It goes way back in computer science, the notion of like a message broker or something, where you have some server, some piece of software sitting somewhere that you can publish things to, and other programs can subscribe to that server, and they can be notified when people publish things to that. And so we've created a simple implementation of that idea. I'm not going to execute these things because these things are already running. But so we have this notion of this create channel function. So I can create a channel. It's a named thing on some server. This is our server, channelbroker.wolframcloud.com. So I create a channel with a certain name, and then I can send things to that channel. And then other clients can subscribe to that channel. They can listen on that channel. So when I push something at that, send something to that channel, they will be notified. So this channel receiver function is the Mathematica function that will be executed when the receiver gets the message. So then I can say channel listen. So if I executed this line, which is already running, that would set Mathematica up in a state where it's in a background thread waiting for something to come in and respond to it. So this is the magic, this listen thing, this channel listen is the magic that puts Mathematica into a state where it's ready to have things pushed at it. All right. So I have no idea what this receive function, channel receiver function does, so let's just make a simple definition for it. This is something that's just going to print the arguments. I don't know what it takes, so let's just try it. We say channel send to ch42. I guess I didn't execute this. So if I say channel send, I get some message. So it looks like nothing happened, but because this came in a background computation, it shows up in the messages window. So there it is. This is just my receive function executing. I printed the things out. So I can see that my receiver function gets this association with various elements in it. But you see raw data goes to 42. So the raw data element is the thing that I sent. So I just need to write function. When I want to write a receiver function, I just pick out the raw data thing. That's the thing that the other side sent. All right, so I'm going to write a new receiver function that's going to put up a display. Now, we'll see what this does in a second. So now that I've done this, I've set something up in Mathematica to happen when. So now, let's try this. I've already deployed this Wolfram Alpha is already doing this. All right, so we say, Alexa, ask Wolfram Alpha, what is the 15th prime number?
The answer is 47.
There we have it. So you can't really see that because it's blown up to tiny little things. But I just I asked Mathematica to respond to this message coming in by opening a new window, zooming it, and executing the Wolfram Alpha function. So this is the idea. This thing is sitting in my living room, and when I ask Wolfram Alpha for things, it can send me an answer back, but it can also put up a screen of information. So anyway, this is just a sample of the sort of thing that you could do to really enable some powerful visual output from the echo. So let's try, just for kicks, see if I can break this. Alexa, well, let me close that. Alexa, ask Wolfram Alpha to integrate sine x from 0 to pi. Try it one more time.
The answer is approximately 15.708.
There we go. It's actually not incredibly interesting Wolfram Alpha output for this. I thought it might be a little more useful, but in any case. So there we have it. Visual display from Wolfram Alpha, without hands-free visual display from Alexa skill, using the Mathematica as the sort of the client to do this. So I'm not going to show the code in any case. All right, so finally, I'll talk about this time tracker app. Now, I'm sitting in my office, Alexa's in my office, and I think, one thing I've never done, there's various time tracker applications, and sometimes Wolfram wants to know if people spend their time for progress reports and things, and I've never been able to keep any kind of discipline with keeping track of when I work on things. It's just too much effort. If you have to go and click something, even just having to go click something is too much. I sit down and start working on something, I never think or have time to go do something to say, okay, now I'm working on project X. But I thought, well, with Alexa sitting right here, it would be pretty easy just to say, I'm working on this project now, or I've switched to a different project, things like that. So I thought maybe I can write a little time tracker. This could be actually useful. It's a perfect example of the always-on nature of Alexa. So my goal is to use her in my office to help me keep track of time spent. So a voice interface would be things like, tell time tracker to start project XYZ, or tell time tracker I'm switching to some other project, or tell time tracker I'm taking a break, or I'm going to sleep, or something. These were all things that would. So she's running now, and so Alexa, ask time tracker to list my projects.
You have 4 projects with names Meeting, Talk, Cloud 4136, and Kernel Forking.
Right. So Cloud 4136 is those are numbers we use to keep track of projects in our project tracking system. Now, this data is not real. I actually used this a while back when I was first developing it, but I don't have any real data for a while, so I kind of put in some fake data just for sample. But the idea is that when I could go and went to a meeting, say I would say I'm going to a meeting. So you can ask things like, so Alexa, ask time tracker how much time I spent on project meeting last week.
You have spent 7.25 hours on project meeting.
So, Mathematica is very good with doing these sorts of computations. I just sit down and I say I'm going to a meeting, I'm coming out of a meeting, and it keeps track. And I can ask for things like, how much time I spent. But what I also want is I want a visual display. I want to obviously just voice output for something is, it's not really going to be suitable for understanding how I'm spending my time. I want some sort of visual display. So how would that work? The idea is that I want to use the report generation feature of the cloud. So at the end of every operation that changes the data, I'm starting or switching to a project, I want to automatically generate a report that I can view in a web browser, maybe, or on my phone, that will show me maybe some plot or various ways of representing this data. Of course, Mathematica is very good at visualization, so I can create all sorts of fancy plots and reports. Now, one reason I want to do this in a scheduled task, I don't want, when I say I'm stopping project X, I don't want the voice interface to delay while this project report generation happens, because it could be time consuming. And I also don't want there to be a delay when when I go to the page, I don't want it to have to do work then. I want to generate this thing sort of in the background. So I schedule a task that runs in the cloud to generate this report, and then when I go to it, it's all ready for me to view. So this is the Wolfram programming, development platform website. Over here, in my cloud files, I have various files I've created, and in reports, this is where my reports are stored. I've created a template notebook, which is trivially simple. This is not even close to a real user interface, but I've created a notebook that just has a title and this little slot here. I don't know if you've ever used the notebook template feature. This is just the notebook template feature that's been in Mathematica for a little while now. I just have a slot called plot, and so this is the thing that's going to be filled in, replaced by data when the report is generated. So this is the template for the report generation. Some process runs, which fills in the slot values and produces a result notebook. So I just created this just here in this interface by adding things and typing, and I've created this file. All right, I don't have time to talk about this because it's a little complicated, but I've got this. There's a thing called the document generator, which is really just a fancy type of scheduled task. It's designed to run. You can run it manually or can run it at intervals in the cloud. It takes a file, the template. That was the file we just saw that had that empty slot for the plot. It takes the source of the data. This is the data. This is just a file into which that plot goes to some data that is the plot will live in that file. It will simply run that template with that data. So my code in the Wolfram, in the time tracker app, writes out this template data.m file every time I change the data. And then when the report runs, it gets merged with that template to create a report. And then this is how I can, so when I don't do this on the web, I'm just showing you what it looks like. My code runs this line, my time tracker app runs that line to generate the report. So the report it's scheduled. This none here is the default schedule. It doesn't ever run. I could make it run hourly if I wanted or something like that, but it doesn't run by itself at all. It only runs manually when I execute this. So this is what I execute inside my program elsewhere. So anyway, so I can go here and I can click on this and I can see, open latest report, and it shows up. Now, it opens in this interface, but if I change the URL to www, it will open without all the framing around it. All right, so, and unfortunately, the plot, which I spent so long crafting beautifully, doesn't look quite right in the cloud. I'm not sure whether it's because the cloud is running 10.2 and I built this with 10.3. Could also be some small issues with cloud graphics rendering. I'm not sure, but in any case, here is my time tracker report of sort of a Gantt type chart of how I'm spending my time. Now, oh shoot, I'm really running long. But the idea here is that I have a web page that I can go to in a browser, on a phone, whatever, and I can see a report. And I could have multiple reports that represent the state in various ways, deploy to the web so that from any device or anytime I want, I just go to this page to see, my time tracker data. So if I was a commercial developer and I was trying to create a time tracker application to sell to people, of course I would want people to be able to go and get reports. This is an example of how I could, as a trivial example of how I could create and deploy these things. Okay, so in conclusion, I hope that I've been able to enlighten you about some ways that you can use the cloud technologies. I really do enjoy this device. I think people should look into it. I recommend getting one. And in conclusion, I have the code, this Alexa application packlet that I wrote for this will be available. It's not really polished yet, but before long it'll be available. You can run this line, packlet update of Alexa, in your copy of Mathematica. If it works, it's there. If it says there's no packlet called Alexa, I haven't done it yet. That's how you'll know whether it's ready or not. And then, of course, this notebook is available from the website. Okay, thank you very much.